Hello and welcome to Data Detectives. Today I have got an exciting project for you all focused on advanced SQL and Power BI. We are looking into the IMDB Movies Dataset, which consists of 6 relational tables. Our journey will begin from SQL, where we will tackle more than 15 problem statements ranging from beginner level to advanced level. You can find the SQL file to import the dataset in the description along with the problem statements. In our next video, we will take our findings and bring them to life in Power BI dashboard. So, if you are ready to flex your SQL and Power BI knowledge, make sure to check out the enclosed SQL file and problem statements below. Don't forget to subscribe for more informative and helpful videos. Thanks for joining and let's get started with our project. So let's start with our advanced SQL project, which is on IMDB Movies Database. We have already created the database. The query for creating the database is available in the description below. You can download the query, run in your SQL, and it will create a database. And now we will be using that database to solve the multiple problem statements that are available with us. Okay. So to access the database, we will write use movies because we will be using this database. Once this is successfully run, let's see how many tables that is available with us. You can see in our movie schema, we have the tables which is actors, directors, genre, keywords, movies and ratings. So before doing or before performing any SQL analysis, let's explore what are the tables available and then we will start with our problem statements. Okay, so first we will see the first table, that is select star from actors. We will write select star from actors. We will run this query and you can see that we have multiple actor names and their FV or you can say Facebook likes on Facebook. Then let's explore our second table, that is select star from directors. It will be containing the detail of all the directors. This is directors, name of the directors. We have director ID and we also have director Facebook likes. Now let's explore the genre table. We will write select star from genre and let's see the genre table. This is the genre. We have different genres: action, adventure, animation, and we also have the genre code which is depicted as G code. Then we will see our fourth table, that is the keywords. It will consist of all the plot keywords that are available in the database. So we will write select star from keywords and this is their keywords available. Like in some of the plots of the movies, it is written as 12-year time span, 14th century, 16th century. There are other things as well, actor, addiction and all these things. So we will be doing some analysis on keywords also. Then let's see our main table, that will be our facts table, which is movies table. It will be consisting of all the major data available. We have movie ID, we have movie title, then we have the color, then we have the languages, we have the country, then we have the content rating, we have the title year in which the movie is released, we have the duration in minutes, then we have the gross revenue, we have the budget which is also in dollars, we have their IMDB scores, we have the director ID. So this director ID will be having some relationship with the directors table. We will do using the joins as well. Then we have the genres. Here you can see that the genres is in a form of a text separated by a delimiter. So we will do how to do these kind of analysis also. Then we have the plot keywords, which is also a kind of a string or a text that is available. We have the other columns like num voted users, number of users for reviews, critics for reviews. Then we have movie Facebook likes. Then we have the actors that performed in that movie and the face number in poster. Okay. Now let's see the last table, that is select star from ratings. Let's run this and this will give us the details of the content ratings, whether the movies are rated PG-13, approved, TVMA and all these things. We have the meanings also available, like This is the meaning of these content ratings and the details and the R code. Okay, so these are 6 tables that are available with us. Now we will start our problem statements that is available in this project. The first problem is, so these are the beginner level questions. In the starting we will be dealing with the beginner level questions, then we will increase the difficulty level, we will go to intermediate, and where it will be consisting of mostly join problem statements using join, group by and all these things. Then we will move to the advanced section where we'll be using stored procedures, subqueries and all those things. Okay, so the first problem is, what are all director names and the total count of unique directors in the directors table. It is already mentioned that we have to see in the directors table along. Okay, if you are following along with this video, just pause the video and try to solve this question, and later on you can see the solution. Okay, so the first question is, what are all director names and the total count of unique directors in the directors table. So for that purpose, first of all, let's explore the complete table. So for that, we will write select star from directors. We have already seen this earlier also. We will write select star from directors and we will run this query. Okay, so this is the table that is available with us. Now we have to extract only the names. So for extracting the names, we will just write the column name, and the column name is directors from directors table. Okay, so when we will run this code, or you can say when we will run this query, you will get the name of all the directors available in this directors table. But the next part is, we have to count the number of unique directors available. So for that purpose, you have to use the functionality of distinct and account function, which is an aggregate function. So we will write select, then we will write count because we will be counting the distinct, then we will write distinct, and in the distinct we will write directors. We will close this, and where we are extracting all these details, we will be extracting all these details from the directors table. So we will write directors and we will run this query. So here you can see that the total number of unique directors that are available are 1878. If you want to give some alias name to make it more presentable, you can write as total number of directors. Okay, you can run this query and you will get your output in the alias name, that is total number of directors are 1878. Okay, I hope it is understood. Now let's move to the next problem statement, that is we have to extract or what are all actor names and the total count of actors in the actors table. Okay, so now we will do this. We have to work on actors table. So let's first copy the problem statement. Okay, and we will do the same analysis that we have done in the previous question. We will just write, first we will explore the complete table, select star from actors, we will run this query and you get all the names of the actors. Now what we will do is we will write select, we want only actor, so we will write select actor from actors table. Okay, let's run this query and you will get all the names of the actor. Now we want to count the distinct, or you can say unique actors. So for that purpose we will write select, then we will again write the count, and we will be using the distinct function, and in the distinct function we will mention actor. We will close this bracket and we will write from actors. So we will run this query and you will get the total count, which is 1218 actors are available in our actors table. Okay, so we have completed this second part also. Let's see the next question, which is our third question. What is the color language country and title year distribution of movies in the movies table. So to attempt this question by yourself, you can take the help of group by statement, because here we want to group our data by different fields. So try it yourself. Just pause the video and try to get the color, language and country and title year distribution of movies, and later on you can see the solution as well. So to do this question, first of all, we will explore the complete table, that is select star from movies, and if we just run this query, you will get all the details available. Now we will want to explore using the color, so we will write select color, and since we want to see the distribution, so we will count the movie ID, because this is the distinct column available. So we will write select color comma count movie ID, and we will be giving alias name as total number of movies, or we can just write number of movies. This is the alias name, and we will write from movies table, and we will be grouping our data by color. Okay, so if we just group it by color, what we will get this distribution, that the color movies are 3919, the black and white movies are 136, and there are two movies for which there is no detail available. That's why it is showing you a blank column. Okay, now if you want to see the language distribution, we will just write select languages, or the structure of the query will be same. We will write select languages, then we will write count movie underscore ID, and here we will also mention number of movies, and we will write from movies, and we will group by languages. Okay, let's run this query and you will get the language distribution. Now let's suppose you want to sort this data descending wise, so we will write order by, and how we want to order, we want to order it by the second column, so we will write order by 2 in descending order. So let's run this query and you will get the order by number of movies. So the highest movies are as expected of English movies, which is 3829. Since the data set is from the English language, therefore it has maximum number. Then we have French movies, Spanish, Hindi, Mandarin, German, Japanese, and so on. Similarly, you can do the current country wise distribution and title year by year wise distribution of movies. The structure of the query will be same. You have to just group by your data by the field that you want to use, and you have to just count the number of movie IDs. Okay, here you can see that we can create a stored procedure also for doing this kind of function. Later on in the other problem statements, we will explore that as well, when we will understand how to use the stored procedure. On when we will see the problem statement of stored procedure, we will explore that as well. Like just by giving the name of the field, we can create a procedure that by which we can extract the field wise distribution, and fields can be multiple that we want to give. Okay, so this is our third problem statement. Let's explore the fourth one, which is what is the highest and the lowest grossing, highest and the lowest budget movies in our database. Okay, so let's copy this problem statement, and for that purpose, or for purpose of this question, you have to use the maximum and the minimum aggregate function. So you can try this question by yourself and pause the video, and later on you can see the solution. So to solve this question, where we have to calculate some highest or the lowest value, or you can say the minimum and the maximum values, we use or we take the help of maximum and minimum function. So how we will write? First of all, let's see the complete data. So the complete data is this, that is the movies table, and we have two columns, that is the gross revenue column and the budget column, and we will take the help of these two columns to extract the details or the get the solution of our problem. Okay, we will write select max gross from movies table. What it will give us? It will give the maximum value of gross revenue, which is this value. But here we are getting just the value. We are not getting any other details of this movie for which the gross revenue was maximum. So how to extract that? We have to take the help of the subquery, because we will include this query, that is where we are getting the maximum gross revenue, to extract any other thing. So we will write select star, because we are extracting everything. We will write from movies table, and in the where statement we will add this query, that is where gross is equals to, we will open a bracket and we will just copy this query like this, and we will close this bracket and semicolon. So what it will do is, first it will evaluate the inner query, it will get the maximum value, and it will equate the gross value or gross revenue with this maximum value, and it will place a condition, because we are using the where statement. So whenever the gross revenue is equals to this maximum value, it will give the details of all those movies. So when we will run this query, you are able to get the details of the highest grossing movie which is taken. The other details are color, English, US, and here you can see that the gross revenue is equals to the maximum value. Similarly, if you want to see the lowest, you can copy and you can place here, and instead of maximum we will write minimum. And let's run this, and here you can see that the minimum gross revenue is $162. It may be possible, and the movie name is Valentine's Day. Similarly, now let's see the highest and the lowest budget movies. So we will just copy this query, and now instead of using gross we will use the budget column. Okay, and let's first check the maximum value. So we will write here budget, and we will see the movie with the highest budget, and this movie is this movie, that is the Bounty, and it is in Korean language. We can place other conditions as well, like if you want to only see from the US, you can select that the country should be US. So in that condition it will give your output, but here we are not doing any kind of other conditions. We are just placing general condition that we want the maximum value of budget, so we are getting this output. Now let's suppose we want to see the minimum value. So for minimum value we will replace this max with minimum, and when we will run this code, here you can see that we have multiple movies for which the budget is mentioned at 0, and here you can see there are number of movies with the budgets equals to 0. What it actually means is that for all those values for which the budget was not available, I think in the database it is mentioned at 0. So we don't want like this. Actually we want to exclude all these blank values where budget is mentioned 0. So how we can do this? We can give a one more condition inside our inner query, and we will write select minimum budget from movies where budget should be greater than 0. Now what it will do is that first of all it will evaluate inner query, and it will give us the minimum budget excluding the 0 value. So if you just run the inner query, you will get this value, that is 218. Now when we will run this query, the complete query, you will get the details of all the movies. Here the movie is Rocky Balboa and the budget is mentioned here, and this is the gross revenue. We don't know whether these values are right or wrong. Like what is it a correct gross revenue or is it a correct budget? But from the database we are getting this solution. Okay, I hope this is understood. Now let's move to our next question. So the next question is, retrieve a list of movie titles along with the column indicating whether the movie is above 120 minutes or not. So 120 minutes is more than 2 hours or not. So let's go down. Let's paste this problem statement, and we have to retrieve a list of movie titles along with the column indicating whether the movie duration is above 120 minutes or not. So how you will do this? You can pause the video, and you have to do this with the help of the case statements that is available inside the SQL, for which is used to make multiple cases, like if condition that is available in other programming languages. Similarly, you have to take the help of case statement. Okay, now let's see the solution of this fifth question. We have to retrieve a list of movie titles along with columns indicating whether the movie duration is above 120 minutes or not. So how we will do this? We will write select, because we want the movie title, so we will write movie underscore title, comma. Now we will create some cases. Case when duration is greater than 120, we have a duration column available which is in minutes, so we are creating one condition, that is when the duration is greater than 120, then it will create a column which is above 120 minutes. And here we can add a one more when condition, or we can directly use else condition, where we will just mention the text that we want to show in the column, which is below 120 minutes. Okay, we will end this case statement, and here we will give the name of the query, or sorry, we have to give the name of the column for this case statement. And what we will write, let's write category. This is the name of the column, and after that we will write from movies. So this is our compulsory statement. When we will run this query, here you can see that we have movie type, title and category above 120 minutes, above 120 minutes, below 120 minutes, and so on. Let's suppose you want to verify your result, so you can also print duration so that you can cross check your answer. Here you can see that if the movie is, let's say, Shawshank Redemption, the duration is 142 minutes, so it is categorized as 120 minutes, above 120 minutes. If the movie is less than 120, that is, for example, Decalogue, which is 55 minutes, so it is categorized as below 120 minutes. So here we have used the case statement. Similarly, you can create multiple cases as per the requirement. Okay, now let's see the next question, which will be the sixth question, that is, find the top 5 genres based on the number of movies released in the last 5 years. So we are moving to the intermediate level. Here you have to find the top 5 genres. So just pause the video and try to solve this question, and later on you can see the solution. So here it is mentioned that we have to find the top 5 genres based on the movies released in the last 5 years. Here we don't know what is the last value in years, so first of all let's explore which is the last value in the years column. So we will write select max title year from movies. Okay, let's run this, and here you get that the maximum year is 2016. So we will take the use of this. Now we want the top 5 genres based on the number of movies. So how we will do this? We will write select. Let's first explore the complete table. Select star from movies so that we can see what columns we have to use. We have this movie title, color, languages, and we have this genre. So we want top 5 genres, so we will write select genres, comma, we will count star, and now we will mention from which database we are taking. We are taking it from movies database. Okay, so we will write select genre, count, comma, count star from movies, where we will now place a condition where title, year is greater than, and here we will use this query, that is where title year is greater than this value minus 5. Okay, so what it will do is it will take the values after uh, 2011. Okay, now we will again write group by, we are grouping our data by genres, group by genres, and now we want to order our data in descending order, so we will write order by 2 in descending. So let's see what we are getting from this query. Here we are getting comedy, drama, comedy, drama, drama, romance, and like this. And since we want only top 5, so we will limit our data by 5 values. So this is our complete solution. We have comedy with highest number of count, that is 37. We have drama, which is 30. We have comedy drama 28. We have drama romance 20. We have comedy drama romance 80. Here you can see that when we have solved this question, we have used this genre column. Okay, but we have a genre table as well. When you have seen the complete exploration, if I just write select star from genres, okay, when we will run this query, you can see that we have genres in this table as well. So later on we will see how to join these two tables and extract only using the individual names of genres. Here we are just working on the genre column available, but we will do this the same question once we understand how to extract the individual genres. Then we will try to count the top 5 genres based on the number of movies it has been mentioned. Okay, so this is how you solve the problem statement number 6. Now let's move to the problem statement number 7, that is retrieve the movie titles directed by the director whose average movie duration is above the overall average duration. We have to extract the movie titles that has been directed by the director whose average movie duration is above than the overall average duration. Okay, you can pause the video here and try to do it yourself. Later on you can see the solution. So to solve this problem, first we will do step by step. We will write select average, and we will get the average duration, which is select average from movies, and we will get the average duration of the movies or the total overall average, which is 109.4008. Okay, now we want to retrieve the movie titles directed by the director. If we only want the movie titles whose average duration is above overall average, we can simply use the where condition. But first we have to group our data by the director, then we can solve for this problem. So how we will do this? We will write select, and we will be selecting the director ID, and from which table, from movies table. And what we will do is we will write a group by clause, that is group by director ID. And since we want the average value, so we will write having average duration greater than this value, that is the overall average. So we will write here like this, and we will close this. So what we will get from here, we will get all those director IDs for which the average duration is greater than the overall average. And now since we want the movie titles, what we will write, we will write select movie underscore title from movies. Now we will place a where condition, where director ID in, we will use in operator, and we will enclose this complete query inside the bracket. And when we will run this query, we will get the name of all those movie directors for which where, so we will get the movie titles, so we will get the movie titles of all those movies for which the average duration of the movies for that particular director is above the overall average duration of the movie. So these are those movie titles. Okay, I hope this is understood. Now let's move to our 8th question, which is calculate the average budget of the movies over the last 5 years, including the average budget of each movie. We have to calculate the average budget of the movies in the last 5 years, including the average budget of each movie. So let's try to solve this. You can pause the video and try it yourself. Later you can see the solution as well. So how we will solve this problem? We will take the help of Windows function. You can see we will write select, and we want the movie titles so that we can see. Then we want the average budget, so we will write average budget, and here we will use the over function, where inside over function we will be ordering our data order by title year, and then we will write rows between preceding, we will write rows between two preceding and current row. Okay, and we will mention alias name, that is last 3, or we can mention average budget last 3 years, and we will write here from movies. Okay, we can mention a condition where title year is not null. Okay, now let's try to see the solution. Here you are getting the movie names and average budget in the last 3 years, including the average budget. Okay, so we have to calculate the average budget over the last 3 years only. That's why we have used this Windows function, and we are getting the values accordingly. Okay, so this is how you can solve for 8th problem statement. Now let's see the 9th problem statement, which is retrieve a list of all movies with their genres, including only those genres that have more than 5 movies. Okay, so you can try to solve this question as well. Later on you can see the solution. So to solve this problem, let's do step by step. We will write select genres from movies table, and we will group our data by genres, and we will write an having clause having count star greater than 5. So what it will show is, it will show only those genres for which the count of movies is greater than 5. Okay, till this point we have got us part of the solution. Now since we want only the list of movies, what we will do is, we will write select movie title comma genres from movies where genres in these genres. Okay, like this, and we will run this complete query and we will get our solution, and we will get only those movie titles for which the genre is having more than 5 movies. Okay, so I hope you have understood this problem statement. Now let's move to the 10th problem statement, which is find the directors who have directed at least 3 movies and have a average IMDb score of above 7. Okay, so how we will solve this? Let's go and try to solve this. You can pause the video and later see the solution. So we will write select, let's select everything from the movies table, and we will be inner joining it with directors table. Okay, and how we will be joining it? Let's give some alias name mnd, and on m dot director id is equals to d dot director id. Okay, so if we just run this code, or if we just run this query, you will get the complete table where you have all the columns from both the tables. We have directors as well, we have director IDs, and we have the movies table. Now what we have to do is, we have to find only those directors who have directed at least 3 movies and have an average IMDb score of above 7. So what we will do is, let's select only the director names. So we will write d dot directors. Okay, then we will write count star as movie count. Okay, and we will also give the IMDb score. So we will write round average IMDb underscore score comma 2. We are rounding it off to 2 decimal places, and here we are giving an alias name as average IMDb score. Okay, we are getting this data. Now we will group our data by directors. So we will write d dot directors, and later we will place some condition having we want the count of the movies at least 3 movies. So we will write count star should be greater than equals to 3, and also we want one more condition, that average IMDb score should be greater than 7. So we will write this average IMDb score should be greater than 7. Okay, let's order our table in the descending order of we can use any column. Let's use third column, that is the average IMDb score, in the descending order. So let's run this code and let's see whether we get our solution or not. So here we can see that the name of the directors are Christopher Nolan, Sergio Leone, Pet Docker, and all those things. Then we have their movie counts, which are either 3 or greater than 3, and then we have their average IMDb scores, which are greater than 7. So this is how you will solve this question. We have applied here inner join, then we have applied group statement, we have also applied having statement by putting conditions on our group data, and we got our solution. Okay, now let's move to the 11th question, which is list the top 3 actors who have appeared in the most movies, and for each actor provide the IMDb scores of those movies they appeared in. Okay, So this is our 11th question. So to solve this problem, let's explore first of all the movies database. We have this select star from movies. We have executed this and we have able to see that actors are mentioned like this. That is, they are mentioned as a text base, or you can say a string, where the name of the actors has been separated by the delimiter, that is this pipe icon. Now first of all, we have to extract the individual names from these complete movie list, and then we are can able to count the uh, number of appearances of all the actors. So for that purpose, how we will do is, let me just show you. We will write select a dot actor, because first of all we will be joining two tables, that is actors table and the movies table, and we will write count. Since we are counting the number of movies, so we will write count star underscore movie count. And also since we want average, so we will write round average IMDB score comma to s average IMDB score. Okay, so we want these three values from which table? From movies table. And how we are joining this table? We are inner joining. Here we will use left join, and we will be concatenating this. We will write from actors table A, and we are left joining it with movies table M. And how we will write concat, and here we will mention the delimiter, that is this pipe sign, comma M dot actors, comma, since this is the way the actors has been mentioned, or the names of actor has been mentioned like this, like concat, and we will use wildcards percent, comma a dot actor, comma person sign, and we will close this. Okay, then we will group our data by a dot actor, and we can order our data by movie underscore count in the descending order. Okay, so if we just run this code, you get the actor's name, you get their movies count, and then you get the average IMDb score of those actors. Now we have to extract the top 3 actors who have appeared in the most movies, and for each actor provide the average IMDb score of the movies they appeared in. So here we can just include limit 3, and it will give the name of the top 3 actors. Okay, so we are getting top 3 actors are Robert De Niro, Morgan Freeman, and Matt Damon, with a movie count of 47, 42, and 37, and the average IMDb score is 6.7, 6.95, and 7.08. So this is how you can get the top 3 actors who have appeared in most movies. Why we have used this statement? Because the actor's name in the movies table were available in a text based format, or you can say in a string based format, separated by some delimiters. So we have to find the names from that, then we can count the number of movies in which that actor appeared it, and then that we have count using the count star. And similarly we have actually calculated the average IMDb score. Okay, So I hope this is understood as well. Now let's move to the next question, which is the 12th question. We have to for each year find the movie with the highest gross revenue and retrieve the second highest gross revenue in the same result set. Okay, so let's copy this question and let's paste here. You can try to solve this question by yourself. Later you can see the solution. Here we will be using taking the help of Windows function partition by, and also we will see using the common table expression. Okay, we will create a temporary table using CTE, and using that CTE we will get our solution. Okay, just try this and later you can see the solution. So to solve this question, first of all, let's explore the complete table. Select star from movies. We will run this and you can see the complete table. Now, first of all, we will create a common table expression, that is CT. We will write with, that is used for CT. We will write ranked movies, and here we will create a bracket, and in this bracket we will create our CT. We will write select movie title, comma, gross, comma, title, year, and comma. Now we will write our partition part or Windows function block. We will write row number over, and in this we will mention partition by title, year, because for we want the answer for each year, so we have to first create the partition. So we are creating partition by title year and we are ordering it by the gross revenue in the descending order, because we have to create for each year and we have to find the highest and the second highest. That's why we are ordering it by, or you can say sorting it by, the gross revenue, and we will mention the name as new rank, and we are getting this detail from movies. Okay, so if you just run the inner part, let me just show you the inner part. Here you can see that we have this new rank 1 2, we have 3 ranks 1 1 1 2, like this. Okay, so we have created CTE. Now we will use this CTE to get our final result, that is the movie with highest grossing and the movie with second highest grossing each year. So we will write select title, year, and then we will write max case when new rank equals to 1, then we have to show the movie title, and we will end it and we will name it as highest grossing movie. Similarly, we will write max case when new rank equals to 2, then we have to show the movie title, and we will end this and we will write it as the second highest grossing movie. Okay, and from which table we will be getting all this? From the ranked movies. So we will write ranked movies. This is the CT that we have already created. Then we will place some condition where new rank should be less than equals to 2. We will be grouping our data by the title year. So we will write title year and we will order by title year in the descending order. So when we will run this complete query, here you can see that in the 2016 year, the highest grossing movie was How to Train Your Dragon. Second was Touching the Void. Then in 2015, we have 7 Years in Tibet. And then the second highest was Coal Miner's Daughter. And like this, we have sorted or get our detail for every year, and we are getting the highest grossing movie and the second highest grossing movie. So here we have used CTE, by which we have created the ranks. Then we have used that CTE to get the highest grossing movie and the second highest grossing movie using the partition, and we have get our solution. Then we have grouped by title year, and we have ordered it by title year so that we get in the decreasing order of the year. Okay. So with this, we have completed the 12th question. Now let's see the 13th question, which is create a stored procedure that takes a director ID as input and returns the average IMDb score of the movies directed by the director. So here we will be working on the stored procedure. You can try it yourself. Later on, you can see the solution. So to create a stored procedure, what we will do is we will start by delimiter, and then we will write create procedure, and in create procedure we can give any name. Let's give a name of our procedure average IMDb score, and inside this we will mention the input that we have to give. This is the input, and here we mention d underscore id. This will be the input id that we will take, and the data type of this will be varchar. Let's close this. We will write then begin, and inside begin we will select, and we will be calculating the average IMDb score. So we will write average IMDb score from movies where director id is equals to d underscore id. Okay, we have to check whether the director id is matching or not. Then we will semicolon, then we will write end, and we will change the delimiter back to semicolon. Okay, so let's run this, and we have created a procedure. Now let's call this procedure. We will write call average IMDb score, and inside this let's give any director ID. When we will run this, it will give us the average IMDb score, which is 7.65. Okay, so this is how you create stored procedures, and with this the stored procedure we can automate any kind of query that we will use frequently. Okay, now let's see the 14th question. We have to retrieve the top 3 movies based on the IMDb score, including their ranking. Okay, so this is a simple question. Here you have to just use the rank function, and with the help of rank function you can solve this. So how you will do this? We will write select movie title, comma, IMDb score, comma, and here we will use rank. And how we will want to get rank over order by. Here we don't want any partition, we want order by IMDb score, and in descending order, and this will be named as ranking. From which table? From movies table where IMDb score is not null. This is the additional condition we are pressing. Then we will write order by. How we want to order it by? Order it by IMDb score in descending order, and we want to limit our data only 3, because we want the top 3 movies. So when we will run this, you get the first movie Shawshank Redemption with the IMDb score of 9.3 and the ranking is 1. Then we have Godfather with the IMDb score of 9.2 and the ranking is 2. And then we have Decalogue with the IMDb score of 9.1 and the ranking is 3. Okay, we are able to see directly, but we have to give a column with the ranking available in it. Okay, so let's see the 15th question. For each director, list their movies along with their IMDb score and the ranking of each movie based on their IMDb score. So since here we want the rankings for each director, so we have to use the partition by. So let's see how we will do this. This is our 15th question. So we will write select director ID. Then we want movie title. Then we want IMDb score. And then we want the ranking, rank over. Here we will mention how we want to partition. We want to partition by director ID. Okay, we have to make the partitions by director ID, and we want order by IMDb score in the descending order, and here we will mention it as ranking like this. Then we will write from movies table where IMDb score is not null, and we will order by director ID, comma IMDb score in descending order. Okay, so if we just run this query, here you can see that for this director ID we have not available with this director ID, we are getting this ranking. Now if we start from D1001, here we get this ranking for D001 person. The second ranking is for the prestige movie. For this director, the third movie is this. For this director only, the fourth movie is this. Similarly, for director ID D1002, the first movie is Godfather, the second movie is Godfather Part 2, the third movie is The Green Mile, the fourth movie is Inside Man, like this. So the ranks has been partitioned by the director ID, and we are getting their rankings based on the decreasing order of their IMDb score. So this is how we solve different problem statements. I hope you have liked this video. If you have liked this video, press the like icon, subscribe the channel so that you can get more projects related to SQL, Power BI and any data science topics that we will cover. Thank you.